Good morning, students. Today I will teach you the working of binary search tree in your exam in paper 2 for HL students only of IBDP. Trees, they can ask you write a recursive method for the in-order traversal, pre-order traversal, and post-order traversal. They can ask you write or construct a code for a method where you have to insert new node in any tree. So I'm going to explain the Java code with proper diagrams and all, and then I'll help you how to write a pseudocode, because maybe in paper 1 it can come in abstract data structure topic. So let's start with the code. So you can see I have created this project tree code. In this tree code, this is the driver class, public class tree code. It is a driver class. Why? Because it contains main method. So I have created object of BST class here, and then I am performing insert operation multiple times. Then in order traversal, preorder, and then in order traversal after deletion. So if I'm going to run the code, you can see it is working. In order traversal is this, pre-order is this, after deleting 40, this is the answer. So we are going to analyze this code first. So obviously they will never ask you, IBDP will never ask you to write the complete code. They will just ask you to write a part of that code and only the methods. So I'm start explaining from this part. So you can see what is the name of this class. It is BST, binary search tree. In the BST class, we are creating another object root of the BST node class. So let's see what is this BST node class. Now look at the BST node class. In the BST node class, you can see this is the structure. So this means whenever someone will create object of BST node class somewhere in the primary memory RAM, this type of structure will be created where somewhere we have the data part. In that we will hold only integer value, and this part is known as the name of this particular cell is left and the name of this particular cell is right. And what are these left and right? These are again BST node, means they are pointing itself. This means these are self-referential objects. Self-referential objects. When object points same kind of object, we call it self-referential object. So the entire structure, what is this entire structure? BST node. When second time you will create another BST node, means the second object of BST node, it will be created somewhere in memory. And if this kind of structure has been created, then obviously it will have some unique hexadecimal address. So let's say the address is 1AF. So maybe this will hold 1AF. So we can say, okay, the left is pointing the left child of the node. This type of structure we will create. Now let's come to the BST node. Whenever you are creating object like this way, you are just writing class name and you are writing object and not providing any value. So this is the first way of creating object. Another way, you all know how to create object, how to instantiate object. You will just write class name, then you will just write object name. Object name means it's an identifier. Identifier means any valid name provided by developer. Identifier means unique name provided by developer of the code. It should be start with an underscore or maybe letters. It can be followed by digits, a special character, but not other than underscore and $sign in Java. Space not allowed. So class name, object name equal to new class name, then bracket start and close. So till now, you know this type of syntax of creating object. And by this way, we can say we are instantiating object of any class, and this object is actually created and pointing address of some other variables. But in this case, whenever you are creating object like this way, by default it is null. This means root will be created. Root is there. Root is created in memory, but it is right now null. It is not pointing any node kind of structure like this. Because whenever you will create object of BST node type, it will definitely point class property. But in this case, it is not pointing right now. Why? Because we are not using new keyword. So it is just a null value right now. By default, it is null. Then you can see in the BST class root, we are setting root null. But whether in your exam they are giving or not, we will consider that root is null. Sometimes in your exam, they will ask you to write a constructor code in Java to insert new node in a tree. Maybe they are not specifying what is the name of the root node. So you can either choose root, you can either choose had or anything. It is your choice. Now, so we are starting from beginning. Whenever you are running this code, the execution will start from here. What we are doing, we are creating tree. So BST kind of object has been created. The name of this object is tree and it is somewhere in RAM. It is somewhere in RAM. But right now it is not pointing anything. It is null. Then with the help of this object, you are calling class property. Why I am able to call root directly? Because it is default. It is not private here. Okay. Maybe in your exam, they will give you things which are private. Then in that case, you will call accessor. But here, because it is default, it is not private. That's why with the help of object, we can call directly with the just write the using dot operator. So here, with the help of tree, we are calling insert method and we are passing this root, which is null, and 50. So let's see what will be the impact of this calling. So once we are calling this method with value root, which is right now null, and the value 50, is this root equal to null? Yes. What this method is returning? This method is returning entire object. This process is known as instantiation. So this means because you are using new keyword, this means in a memory, a node has been created where data part is 50 and the left part is null and the right part is null. Because you all know this fact, whenever you are instantiating any object, constructor will be created, constructor will be called automatically for value 50 and data is 50, right and left are null. Then we are coming back. Now you can see because initially root was null and you have returned this thing. So return means you are returning back to the calling point. And first time, what was the calling point? This was the calling point. This place was the calling point. So basically, whatever you are returning, it will go to the root. This means this entire structure is known as root now, right now. Let's say because all these three cells are occupying space in memory in a back-to-back manner. So let's say the address start from 1AF. So the address of this particular cell is, let's say, 1AF, let's say. Then this is resolved. Second time we are calling insert method, but we are not initializing this return value to anything. We are just passing this root. And what is this root? It is actually a object. Object means address. So this means you are passing 1AF, the address of that particular place, and 30. So second time you are taking entry here. Second time you are taking entry here and you are passing 1AF address with the key value 30. Then we are checking, is this root equal to null? Is this root is equal to null? No, it is not. No, it is not. Then you are here. Is this key, which is 30, is lesser than root dot data 1AF dot data? So what you have, what data part you have in at the address 1AF? 50. So is this 30 lesser than 50? Yes, it is. So you will call the insert method again and you will try to insert this value at the left side because you know this property that left side value is the value at the left, the value of the left child node is always lesser than the root value, and the value of the right child node is always greater than the root node. So this time you are passing root dot left. So what you have in the left part, you have just null. You have just null. So null, comma 30. So you are calling here. This is null and this is 30. Then is this null? Yes, this root. The right now the recent root is null. So you are creating new BST node. So new BST node has been created with value 30, null, null. And whenever this structure has been created with the help of new keyword, this obviously have some address. So this entire structure starts with the address, let's say 2AF. So once you will create this structure, and this structure has been created at address 2AF, so this place will return to the recent calling point. So this is the recent calling point, and this 2AF will assign to root dot left. So what was last time root dot left? This. So now this place is not null, it is holding 2AF and it is pointing this. Then things are resolved because we are done with this recursive call. We are just returning root. So because whenever you are calling things are going in a stack. So first time you call this root for 1AF address. Second time you call it for 2AF address. So once you resolve 2AF, obviously root is again 1AF. You are going back here. So this part has been resolved. This part resolved, this part resolved. Now let's see what is this part. Again, you are calling the same method for value tree.root with value 70. So let's go back to the same method and you can see this time 1AF because this is the address of our root and the 70 is here. Is this root is null? No, it is not null. It is pointing some address which is 1AF. Then we are in here. Is this key, which is 70, is lesser than root dot data? No, 70 is not lesser than 50. Then we are here. Is this 70 is greater than root dot data? Yes, it is. So you are again calling it recursively. And why it is important to call it recursively? Because obviously you can't create new node here and put it at the root node. You will go towards the right side. So this insertion will happening and you are passing root dot right. So root dot right is right now null. So you are passing null with value 70. So you are going back, second call, this is null with value 70. Is this root, the recent root is null? No, it isn't. Yes, it is null. So once it is null, you are creating a structure of BST node. So this is BST node, 70 is here, null is here, and null is here. And the meaning of new is that it will be created with some address. Let's say 3A1 is the address. The hexadecimal number is the address. And once it is created, it will return back to the recent calling point. So this place will be replaced by the return value. And what is this return value? The address of this place 3A1. We are assigning this address to the root dot right, because what is this 3A1? 3A1 is actually the structure of BST node. So 3A1 is here. So this is 3A1 and it is pointing like this way. I will show you this. I will trace this code for one more iteration so that I can show you. We will keep moving sometimes toward left side, sometimes toward right side. So again, we are going back to the calling point and you can see we are here at the place 20. Okay. So we are calling this method again with the value root. So this time address is 1AF, means this address. The key value is 20. Is this root null? No, it is not. Is this 20 lesser than root dot data? So root, what is root? 1AF. 1AF dot data is 50. So is this 20 lesser than 50? Yes, it is. So this means you will try to go towards the left because it is binary search tree and only binary search tree is in your syllabus. So you are calling this method insert root dot left comma key. So what is root dot left this time? What is the left part of 1AF? It is not null this time. it is actually 2AF. So this part is actually not null. It is pointing some other object of BST node. And this object is at the address 2AF, let's say. You are passing 20. So you are here this time. You are passing 2AF with value 20. So first call was 1AF, second call was 2AF. Is this root is null? No, it is not null. Then you are checking, is this key 20 is lesser than root dot data. So right now, what is the value of root? 2AF. What is 2AF dot data? 30. And we are checking, is this 20 lesser than 30? Yes, it is. Yes, it is. This means again you are calling. I'm writing all the calls. 1AF, then 2AF, then third time you are calling this method root dot left. So what is root? 2AF. What is the left of 2AF? Null. So you are calling it for null with value 20, 20, 20, 20. So is this root is null? Yes, it is null. Once it is null, you are creating BST node again. You are instantiating object of BST node. So BST node will be created with value 20 and left and right are by default null because of the constructor. And once you will create this, you are returning back. And what is now, keep track of this point. Whenever you are returning back, you will try to replace this value. So this thing is root dot left. So what is your recent root dot left? So you can see this is resolved. The recent root is 2AF. So the recent root left will hold this return value. Let's say this is 4AB address. So this is 4AB and this one. Then after that, once you will resolve this, again, the root is 1AF and you are returning the root. So you are returning this entire structure like this way. And this part is right now 4AB because these parts are always points. These parts left and right are always point another BST node. So I hope this is clear. Insert method. And they will never ask you to construct this entire code. They will just ask you construct a code to insert new node to the given binary tree. So you can use root directly. You don't need to bother about where we are declaring it because IB is not looking for declaration and things. IB is actually looking for logic, like how you are applying logic. Are you calling recursive method correctly or not? That's it. And you should know how to trace these kind of methods also. Now I will explain you in order, which is very important. In order, pre-order and post-order are important. It came 2 times in the IB, I think. So I'm explaining this. So let's say this type of structure has been created 50, 30, 20, 70, and let's say 60. If this entire structure is created at address 1AF, let's say this address is the entire structure is created at address 2AB, this is 5AC, this is 4A1, this is 3BC. So this is holding 2AB, means it is pointing this. This is holding 4A1, this is pointing this. This is holding 5AC, means this. This thing is null, this thing is null, this thing is null. This is holding 3BC, null, null, and null. And let's say it's not null. Let's say it is 51C is the address. And 51C address is holding, let's say 75 value, and these values are null. Let's say this is the tree. Now I will trace this tree with this method. First time you are providing root. So what is root? Root is the object. So whenever in memory you are creating this is primary memory root. So whenever in a memory, this is primary memory RAM. So when in a memory you are creating any object and the name of this object is root, so obviously it is itself occupying some storage, let's say 6 to 8, let's say this is the storage. But what it is pointing actually, it is pointing 1AF. The left, the data part, and the right part. This is the concept behind creating object. Object are referential variable. They always hold address of other variables. So whatever variables and properties you are creating in a class, they started with some address, and this address will hold by the object. That's why we always say object points other variable. Points means they are holding address of something. So this means root is actually 1AF, and 1AF, from 1AF, this entire structure is created. So let me trace this. First time you are providing 1AF. Is this root not equal to null? No, it is not null because it is 1AF. In order root left. So this means you are calling in order method. First time you are passing 1AF address. Then this 1AF means in order of root dot left. So what is root dot left? 2AB address. And then we are printing root dot data. So what is root dot data? 50. Then we are calling in order. In order root dot right. So what you have in the root dot right? 4A1. So 4A1 address. So if someone really wants to resolve in order traversal where root is at address 1AF, they have to resolve this entire structure. So this means you can't reach to these 2 points unless you will resolve this in order 2AB. So I am solving in order 2AB. In order 2AB. So just a minute. So in order 2AB is resolved, we are going back. We are going back, and this time this 2AB is acting as a root. Is this root not equal to null? True, it is not equal to null. In order root dot left. So what is 2AB's left? So this is 2AB. What you have in the 2AB's left? 5AC. So in order 5AC, this thing. Then print. You have to print root dot data. So what you, at which point you have your root 2AB at, just at the 2AB. So this is 2AB. This is your data. So we are printing 30 here. Then we are calling root dot right. So in order, we are calling in order method again for the 2AB's right. So what is 2AB's right? It is null. So in order null means null. That's it. So this is our first step. This is our second step. Now we are on third step. Third step is that if you want to resolve 2AB fully, you have to resolve in order 5AC. So in order 5AC, we are resolving. So once you are calling this in order method for 5AC, what is 5AC dot left? 5AC dot left is null. Then you are printing root dot data. Root dot data. So what you have at 5AC dot data? It is 20. So 20. Then in order root dot right. So what have you have at the right? Null. So in order null means null. If you are calling in order method for a null, it will return null. It is not returning anything, means it is nothing. So basically the meaning of in order 5AC is 20. 20 only, because the address, the BST node, which is at address 5AC, have left part null. The right pointer is also pointing null, and the data part is containing 20. This means the value is 20 only. This is the terminating condition of this recursive method. Again, I'm telling you, I'm just considering these 1AB, 2AB, 4A1, 3BC, 5AC. I'm not sure what actual address you will have in your memory. I'm just considering the address. Okay. Now, once the terminating condition will come, this will pop out. So all the calls, whenever you are calling any recursive method, all the calls are going in a stack, one by one, one by one. But once terminating condition will met, you will pop out the things in a reverse order. So this is the terminating condition where there is no recursive call after in order 5AC. So the 20 will come back and this place will be replaced. So first, second, this is our fourth step. Means 20, then this 30, and this is null. So we can leave this place. So what is the meaning of in order 2AB? In order 2AB means 20 and 30. So we are keeping this thing here at this place because this is the meaning of this. So this means 20, 30, and then we are printing 50, and then in order 4A1. So if someone really wants to know the in order traversal of 1AF, 1AF means the root node. They are printing 20, then 30, then 50, and then they have to call in order 4A1 because we are here at this point. So let me solve this. I'm going to clear this. Till now, we have resolved. Till now, we have resolved these 2 points. This point is resolved, this point is resolved. The meaning of these 2 points is 20, 30, 50. Now we are resolving this part. So in order root dot write. So what is 1AF dot write? It is holding address 4A1. So 4A1 address. Then again you are calling this method, and this time the root is 4A1. It is not null. So you are calling in order root dot left. So what is 4A1's left? In order 4A1 dot left. So the left part is containing address 3BC. 3BC. Then this part root dot right. So root dot right means we are printing root dot data means printing 70. Just a minute. We are printing 70 root dot data. Then in order root dot write. So what is root dot write in this case? In order, your right part is pointing 51C. 51C. So if someone really wants to know the in order traversal of the right tree, again the same order, left, root, right. So you are solving 3BC. So in order 3BC is equal to, so this is your 3BC. In order, I'm saving this thing somewhere. Now, when you calling it for root dot write means 4A1 first time. Then this is the meaning. These 3 lines are the final meaning of in order 4A1 address. This in order. So first we have to do in order according to 3BC. 3BC, when you are calling back, this time the root is 3BC. Root is not equal to null because it is 3BC. In order root dot left. So what is 3BC left? It is null. It is null. Then what we are doing? We are printing this value, root dot data. So print 60. Then root dot write. So what is root dot write? It is in order null again. And I can show you once you are calling in order for null, let's say you are calling it for null. Is this root not equal to null? No, it is null. This means go back empty-handed. Means this is actually, it doesn't make any sense. In order null means we can leave it. So the meaning of in order 3BC is just print 60. So you are popping out this call and it is resolved, and the meaning of this thing is 60 and then meaning of this thing is 70. So this is the meaning. Now we are resolving in order 51A. So again at the 51C. So again at the address 51C, the in order, the left is null, right is null. So this means it is just printing 75. So the meaning of in order 4A1 is 60, 70 and 75. You can replace all these 3 values here. So the final answer is 60, 70 and then 75. So you can see all these values are in ascending order because in order traversal always give answer in ascending order. Again, I'm giving you summary. We are starting from the root node, and while you are not reaching to the leftmost uh, node of the tree, you will keep calling same method. You can see root is 1af first time. You are again calling for root dot left. So second time left was 2ab. Then you are again calling root dot left, which is, let's say, 3ab. So 3ab. So basically, you are reaching to the leftmost child, and then you are printing the value of that leftmost child. After that, you are going to the root. And after resolving the root part, you are going to the right side. So in order, always say root is in between, left is at the left side, and right is uh, uh, it's the step is left, root, and right. So we are following this. So same way pre-order. In pre-order, root is always printed first, and then we solve left and right subtree. Whenever you will reach to the left subtree, then also the order is same. First print the data of root, then go to the left, then go to the right. So if you will trace, you can trace this on your own, and you can send me picture of your steps. So I will check and I will give my feedback to you. Post order is again same. Post order means root is at the end. So I think post is not here. You can write on your own. Post order method means you are passing root as a parameter, and if it is not null, then root dot left, post order root dot left, post order root dot right, and then you will print the root dot data, because data will be printed at the end in post. Now I'm showing how to find minimum value. This question is important. This question came in IBDP previous paper, where they were asking you, I'm not able to recall properly, but they were asking you either construct a code to find the smallest value of the from any BST binary search tree. If they can ask you this question, they can ask you find the maximum value also. So in a binary search tree, the minimum value will be the smallest value. You can find the smallest value at the left uh, most part, and the maximum value will be at the rightmost part. So I'm tracing this for minimum value. So you can see we are passing root first time. So I'm tracing it here. We are calling min value method, and we are passing root. And what is this root? 1af. Then min value equal to root dot data. So I am writing min value somewhere here. So min value is equal to root dot data, which is 50 initially. So we are considering this 50 is minimum value. While root dot left is not equal to null. Why we are doing this? Where you can find the smallest element at this position. So while this root dot left is not null, because otherwise in all the in all the nodes, the left part always hold some kind of address, but the last node of left subtree always pointing null. So we are traversing this tree till the left is not equal to null. So while root dot left not equal to null, so what is root? 1af. What is 1af dot left? It is 2ab. So first time we are checking, is this 2ab not equal to null? True, it is not null. Min value root dot left. So what is root? 1af. What is root dot left? 2ab. So what is 2ab dot data? So we are fetching 2ab dot data. So 2ab dot data means 30. So this means min value is 30 now. After that, root equal to root dot left. So in first time root was 1af. Now what is root dot left? 2ab. So this means your root is now 2ab. And you are in the while loop. So you will go back and you will check the next value. You are checking the next iteration. What is root dot left? So what is 2ab dot left? It is 5ac. So is this 5ac not equal to null? True, it is not null. Min value equal to root dot left. So what is root this time? 2ab. What is 2ab dot left? 5ac. And what is the what is the data part of root dot left? So root dot left it is 3AC because I'm writing 3AC here. So it is 3AC. So root dot left is 3AC, which is not null. Root dot left is 3AC, and what is 3AC dot data? It is 20. So min value is 20 right now. Then root equal to root dot left. So what is 2AB's dot left? It is 3AC. So now, right now the root is 3AC. We are going back. Is this 3AC dot left? So what is 3AC dot left? Null. So null is not equal to null, false. This time it is null. You are coming out and you are returning min value. So you can see the min value is 20. So the summary is that you are passing root node of any tree in the min value method. You are considering that the value of the root node is smallest. Then you are starting traversal of the left side and you are reading only the left child of every subtree. So root dot left not equal to null. You are just updating min value for all the data part which is coming at the left side, and you are keep updating your root by keeping left side node as a root node. So this is the method. Same way, max. So from my side, this max and min is important. So I think you can do max on your own. It's a simple. If you want to write a max method, integer max value BST root int max is equal to root dot data, where you can find the maximum value, the rightmost corner. So root dot data. So you will try to move towards right side. So while root dot right not equal to null. So this means whenever you will reach to the farthest point of the right subtree, you are just keep running this loop. Max is equal to root dot right dot data, and then you will keep updating your root equal to root dot right, and then return max. This is the code. Now, many times they will ask you, without writing code, explain the recursive method of Inorder traversal. So you can see this is the explanation. So in your exam, you will write. In your exam means in your IBDP HL. This question can come in paper 1 and paper 2, in both papers. So if root equal to null, a BST node is created and returned. This name will be changed as per the question. Maybe they will give you another name. They will give you another name of the node structure. So if root is null, a new BST is created and returned, stopping further recursion. If key is lesser than root dot data, the function recursively call. If key is greater than root dot data, the function recursively call insert on the right subtree. This process continue until an empty position is found for insertion. This is the description of insertion. And you can find description. You have to learn description of all the methods. You have to prepare yourself for this part. They can ask you this part.